So today we are going to get to what transformers are and NLP tasks and, Hugging Face and native TensorFlow keras and transformers in production with TensorFlow extended. Like the deployment part is actually like tomorrow's topic, and we are going to go through a token classification notebook. But today we are going to just have an introduction instead. So I'm going to talk about what we do at Hugging Face. You might have heard Hugging Face with Transformers library. And in Transformers, so Transformers are basically Transformers are basically an architecture that you can do. You can use attention mechanism, self-supervised learning, which I will explain later, and transfer learning. And I'm going to explain transfer learning later, but you can. We are basically providing you the tools necessary to use those Transformers architectures in Transformers library. And we also provide the data sets needed for that. And we are also I'm going to get to what is pre-training later, but we also serve we also host your models basically for collaborative training and collaborating with your team. We basically help you train those models with those data sets, and we help you demo these models and through Gradio and Streamlit and Spaces. And we are also we have also so many integrations with TensorFlow keras and the native keras without transformers as well. So you can host your models in Hugging Face Hub, like any TensorFlow keras model or Transformers TensorFlow keras model. It doesn't necessarily have to be a Transformers keras model. And you can train transformers in a native keras kind of fashion, which I'm going to come later. And in model repositories, we are hosting TensorBoard, and we also demo your TensorFlow keras models. You can also demo your TensorFlow keras models, but back to transformers. So in machine learning, you can just you have this neural network, right? You basically feed images or whatever you want to a neural network, and you train from scratch. This is like a traditional kind of thing. So imagine I have this neural network that I wanted to caption images based, generate a caption based on an image. So I could use something like an encoder decoder kind of network where I get, images features and, encode and then decode to generate the captions. You can train from scratch. In this neural network, I'm looking for a mathematical relationship I could later use to caption different images, basically. And I, convert my image to matrix of pixel values and I create this mapping from words to numbers, which is like the tokenization I have already told you about. And I have this neural network. So in this neural network, I have in the first layers, I have very shallow information. And in the last layers, I have very specific information about my data set. So in the first layers, I have universal information, edge detection, corner detection, stuff like that. And in the last layers, I have very specific features about my data set usually. So I could either train from scratch, which I have to let the machine learn every single thing about data set and the relationship between the image and the captions, or I could do something called transfer learning. So in transfer learning, I basically get the first layers of a model, which contains those universal information. And then I could retrain it on my own data set by putting a classification layer. For instance, if I'm solving a classification model problem, that classification problem is based on, I don't know, cats and dogs and birds. I could put like three, like a softmax layer, like a dense layer in TensorFlow with 3 units at the end, and then retrain again. And this is called fine tuning. And this is actually way better than training from scratch, because like imagine like Google or Facebook has trained this very big model for you, and you can actually make use of it. Like they have trained it on data that has a size of petabytes, and it's a model that has like billions of parameters or whatever. Like it's a very big model. Instead of like starting from scratch using such model, because like at the end what you are doing is the same, like you have like edge detection and then very specific ones, or like in NLP you have like a syntactical information in the first layers, grammatical information, and in the last layers you have features specific to your data. So instead of training from scratch, you are just transferring that information from that really big model to your own model, which is very useful, very handy, and it usually performs way better than training from scratch. And this is called transfer learning, and this whole process is called fine-tuning. So, okay, but what are transformers? So we can use, like, transformers are just neural networks with attention mechanism. And you can use transfer learning with transformers. And another thing is self-supervised learning. And self-supervised learning, I would say, is not unsupervised learning or supervised learning. It's something in between. So basically, in unsupervised learning, you have no labels in data whatsoever. And you do problems like clustering, right? You try to, group the data and try to get that, like groups at the end. And in, supervised learning, you have data with labels. And you try to predict those class labels from your data. So self-supervised learning is something different. It is something like you have like a Wikipedia text, a very big Wikipedia text, for instance, and you are trying to extract like your features inside, like the words inside your data is actually supervising your problem. Basically, for instance, you are trying to solve this problem of trying to predict the next word in a sentence. So you don't really need you don't really need any label in this case, right? You just need a plain text. Wikipedia dumps, for instance. Or you are trying to, like, you want to mask a word in a sentence and try to predict that word. You don't need any labels, but you are not exactly solving an unsupervised learning problem. So these are actually trained like that. Like BERT is trained, which is a very famous transformers model, by masking the word and then trying to predict the word. And GPT-2 is trained by trying to predict the next word. So these don't really need any supervision, like labeling, which is handy because labeling is expensive and it requires like human supervision a lot. We don't want that. And what is good is that, like, we have tasks in tasks in NLP and also computer vision and also audio. And those tasks are like, like you have task-specific data sets, okay? Like, for instance, I have sentiment analysis task, which is called a text classification, actually, in the end. You're trying to classify a text, like assign a class to a text. And you have like sentences and their class labels. And you can basically take a BERT model and fine-tune it on this task and voila, you will have a better performing model than actually training from scratch, basically. And what else? For instance, another one is image classification. You can use one of the pre-trained models again, like vision transformer, and you can classify. You can actually just take the image class, like an image classification data set, and just fine tune your model, and then you will get a better performing model from the one that you have trained from scratch. And same for any other task. So these are basically tasks, and these are actually what you need to solve your machine learning problems, like problems. This can be something like, you have these customer reviews and you're trying to understand your customers, but they are too much. How can you do it? You cannot, just write a rule-based program. It's too hard. Instead, you can use like deep learning, and you can just get a BERT model and fine tune it on a sentiment analysis data set and just use that model instead. So in Hugging Face Hub, as I have told you previously, like we have this hub where everything meets. Like we are hosting models, data sets, everything machine learning related. And here we have like BERT models, like we have tons of models. One of them is BERT for sentiment analysis. Like we have so many models. You can just go over there, look for a sentiment analysis model in your own language, take that and just infer with it and see how, if it's useful for your case or not. Because sometimes you don't even need to train a model. Actually, you just can go over there, take your model, and then just use that model instead of training. Like any other, like you need a text generation model, you can just go over there and use it. You need a question answering model, for instance. You are trying to answer questions in a document automatically. You can just go over there and take that model and just use it instead. And you can also do like you can also upload your own models to collaborate with your team members. So that's what we are actually doing over there. And yeah, so like how can you use this? Like you can make a bot that answers FAQs using question answering models. Like you have these documents that you want to answer your customers. Like your customer is going to ask a question, and this bot is going to like go over your documents and look for the answer. And you can just make a bot that answers FAQs. And you have invoices, for instance, and you can just do an automated information retrieval using token classification models. You can, create conversational agents that speaks like your favorite movie character using conversational models. There is so many to do. And as for pipelines in transformers, we have something called pipelines, which is very useful. So as I have told you, before feeding things to your model, like data to your model, you need to tokenize your words, basically your text. And to do that, like it's a very cumbersome process. Like you need to take your tokenizer, let data pass into it, and then take the outputs and feed it into a model and take the model output, etc. So transformers in transformers, like pipelines actually provide such a nice encapsulation of this whole process. Like it's like a box that has this model and the tokenizer, and you just pass your question and the context. Like for instance, there's this context which is a document, and you are looking for answers in the document, and you can just pass that document and your question and get the answer from that document. Basically, that's what it does. And so, like, you can, for the first ever POC of your, solving your problem, you can just, go into the Hugging Face Hub, pick a pipeline that suits your use case the best, like take the model and just, initialize a pipeline with just few lines of code. And you are just good to go. You have your first ever machine learning product without even training a machine learning model. So you have context and the question, and you initialize the pipeline, question answering pipeline. You can also give like if you have a specific model that you have taken from Hugging Face Hub, you can just give it while initializing the pipeline. If you don't give a model while you're initializing pipeline, it's going to give Distilbert for question answering. And then with your initialized pipeline, you can just give your question and the context, just get the answer, and voila, basically. Another one is text generation, which is like you are trying to predict the next word in a sentence, for instance. Assume that you are writing code. You need like a code generation pipe sort of model, and also assume like you want to generate stories, for instance, and you can just initialize pipeline text generation. If you give it a model, it's going to just initialize with that model, but if you don't, it's going to initialize automatically with the GPT-2 model. And you can just give the text input to that initialized pipeline and just get the answer. Like the answer here being the completed sequence. Like it's a Jedi story here. And if you cannot find a language model that suits your problem in the hub, you can just train it from scratch with a native Keras with transformers. So if you actually know how to use TensorFlow, then you know how to use transformers as well. So let's say you need a model that auto-completes your code. You can pick the GPT-2 model config and train it on GitHub code, for instance. And in transformers, we call PyTorch and TensorFlow models differently to treat our model as a Keras. Like we have like a TF auto model for causal LM because these are initialized differently in PyTorch and TensorFlow. So we call that. And we just set the model hyperparameters, and we have something called add-on weight decay, which is similar to, in TensorFlow add-ons, we have add-on W that you can initialize with the learning rate scheduler. In also TensorFlow, we have add-on, but that's not with the weight decay. And we can just set the model hyperparameters, initialize our optimizer, and then, compile our model. So in transformers, we don't compile with a loss because models have their internal losses. In like classification ones, you can actually, like in text classification, for instance, you can actually give like a sparse categorical cross entropy. But for the rest of them, we have like different losses, and those are internal losses. So we don't initialize with that loss, but we initialize with the optimizer only. And then we fit, like giving the training data, validation data, and number of epochs, just like any other Keras model. And if you'd like to fine tune, so basically for each task, as I have told you, we have like different data sets. And those data sets, like task-specific data sets, are actually can be loaded from our own datasets library as well. And you can just load it, like you can just load for instance, for token classification, we have Conela 2003. So tomorrow, in tomorrow's session, we are actually going to see it, see the token classification notebook step by step. But basically, we use the load dataset function from datasets, and we load the token classification dataset, which is Conela 2003. And we load the token classification model, and we give the model checkpoints, like it can be anything. I'm just going to show you tomorrow. And we, set optimizer and learning rate scheduler, and then compile our model, and then fit the model just like any other Keras model, as I have told you. And most of the people aren't actually even doing this. They are just, in Hugging Face, we have examples. And in examples repo, we have ready-to-use scripts that you can just run. Like with this one, basically does all of these with the pre-processing and everything. So it has like ready-to-use scripts that you can use to train your models, and it's going to do everything for you. And like I didn't write it here, but we have like a couple of cool callbacks as well, if you are familiar with TensorFlow's callbacks. Wait, I must have shown it here. So for instance, we have push to hub callback. Basically, we set it up to push our models to Hugging Face Hub, like TensorFlow models to Hugging Face Hub. You just give your output directory, the tokenizer, and your, like the model ID that you want your model to be stored in the hub. And just while calling your model, just a model.fit, just call the push to hub callback as well. And it's going to push your model to the hub. You can also use TensorFlow callback. And the nice thing about TensorFlow callback is that it basically hosts, like TensorBoard on the repository itself live, that someone else, can see your model's metrics, play with it, etc. And, like a good thing about, like I'm going to show you tomorrow again, good thing about model repositories is that we have a widget over there that you can play with. And if you also want to push your non-transformers Keras models, we also have a function called push to hub Keras that does it. Like it does, if you want to, if you have a team that you are collaborating with, and you are using Keras models but non-transformers ones, you can use this one instead of the other one, and give repo URL, your model, and if you are working in an organization, just give the organization name and you will be good to go. So I think we are on time. I can entertain questions, and also like, I'm sorry, it's my Siri. So if you have any questions later, by the way, don't forget to go over hf.co/discord, and over there we have a community, and we have this channel called TensorFlow User Groups Workshop Series. And in that series channel, you can actually ask your questions about this, even after the presentation. So yeah.
Thank you, Merve. It was amazing.
Thank you for having me.
Well, we don't really have any questions right now, but let me ask you this.
Okay.
So I was curious, for the hub, you can actually host only NLP models or any kind of models. Like it can even be.
You can, yeah. Let me show you. That's actually a nice question. Let me do it like that. So Hugging Face Hub is basically for any models. Let me do it like this. So when I go over the models, I can actually filter the tasks I can do here. And I have like, because Hugging Face started as an NLP library, we have so many NLP models, but we have also computer vision and audio models as well. Like when I filter like that, I have this audio to audio task that basically generates an audio from an audio. I have image classification models that are hosted. I have image segmentations, and I have already I have started something called like I have a Keras organization here if you'd like to join.
Oh.
And for instance, like it's really nice because it also comes with an inference widget. For instance, this is my cat, and this is going to load the model for me, and it is going to segment my cat like in image segmentation, like this. I can just play around. Yeah, it's really good. And like, let me show you Keras IO. I'm trying to build the Keras ecosystem over there. And for instance, I have Inception classifier space. You can also demo your models with space. This is a basic image classifier done with Gradio. I'm going to show how to use Gradio tomorrow.
Okay, thank you.
To build our models, the model demos. Like for instance, I have this cat, and let's see, like this is classified as a tabby cat. Yeah. Yeah,
Nice.
thank you for asking.
You're welcome. Well, I'm actually more of a computer vision person than I am an NLP.
Okay.
That's why I asked.
It sounds a bit like alien language when you start to learn NLP when you're a computer vision kind of person.
Oh, really? Well, actually, like,
yeah, does it?
When I first learned it, like, actually, the thing that I had always a bit of a struggle to understand would have been the, like the trying to understand how all of these words actually, when they are encoded, make some kind of sense. Like, for example, like at first when they introduced embedding, they tell you that usually it remembers the position, like the encoding kind of remembers the position and the meaning. And then I was like, how does it even do that? It's just a bunch of numbers.
So in the as far as I know, like Word2Vec doesn't do it. That's called the approach is called bag of words, because you don't really remember the order of the words, but attention actually, like with the attention mechanism, they have introduced positional encoding as well, which is quite useful actually. Like I remember I was making chatbots, and I migrated the whole thing from like supervised embeddings kind of, like a very, very shallow Word2Vec kind of thing to Transformers one, and the accuracy went up by like 30% or something. It was like crazy.
Oh, that's amazing.
Yeah.
Actually, I wanted to ask you, like, what made like the team that developed attention models think of attention? Like, I know that we humans usually pay attention to things first, like when we are, like when we see something, our brain directly zooms on some kind of stuff. But like when they thought of it first in NLP. They didn't think of it in computer vision. So I'm like, how did they think of it? Like, what brought it?
I would say, if like this kind of confuses me a little, but I'm going to explain for computer vision. I feel like in computer vision, it's more like saliency map. Do you know saliency?
Yes.
So it's a bit more like saliency map. let me try to find the difference between saliency and attention, because I feel like they're a bit similar. So what attention basically does is that, because we have used attention in sequential stuff most of the time, like sequence models,
Yes.
and it captures like the, like you still are trying to get the, relationships between the nearby words and stuff.
Yes.
As far as I know, like in visual attention, they get the, like the convolutional patches still, and then, they try to get the nearby pixels, the
Yes.
relationship between nearby pixels as well. So let me see if I can find like a difference between attention and the saliency.
Oh yes. Do you have any kind of resources you would like to share with the
Yeah,
attendees?
sure.
Thank you.
So this is basically my favorite uh,
Oh yeah, I
my
love his
favorite
tutorials
blog
too.
post. My favorite blog post by J.L. Lamar, and we have like also in, because like this is the whole concept of attention is really long. I didn't want to introduce it today. The another one is like, we have like Raza algorithm whiteboard that explains it from starting from the wait attention. So it is this one. So this starts from, like what attention means. Like it starts from a nice point of time series data, and the, like how you don't actually need all of it, but you want like something like a reweighing to get relevant information instead. And then it goes on, and it is like a series. It doesn't do everything in one video, but it does like it first touches on the self attention, and then, key query value, and then multi head attention stuff. So I would
Nice.
definitely recommend this one. Yeah, it's a
Yeah,
really
thank
nice one. No problem.
you.
Anyway, tomorrow we can do like, we can still live stream, by the way. Tomorrow we are going to do how to build a machine learning demo, and like we will first do like we will go through the token classification notebook with TensorFlow, and then we will basically go through building a machine learning demo, and then deploying your model with TensorFlow extended, you know,
Yes, yes.
and it's going to be a bit longer, so it's best if we leave it today. I'm going to stop sharing. Yeah.
All right, thank you very much, Merv. So, do you mind if I ask you some, like not related NLP questions?
Sure. Sure. Of course.
So, perhaps you would like to tell us more about yourself. Like we usually don't see lots of women in the machine learning field, so it's always nice to introduce them from time to
About
time.
myself.
Yes.
Okay. So
So, how
I
did
am
you get
basically.
started?
Um, so I started actually as a data scientist instead of a machine learning engineer. I have taken this class at school, and I was into like the hype or around, like the AI and everything. And I have taken like two courses. One was optimization with Python, like we were writing optimization and simulation algorithms. And the other one was data science with R. And then I started, like learning R and Python over there. And then I have like, when I graduated, I did, like I tried to learn even more on my own. And I went to boot camps, like I did some mentoring work. And then I landed my first job. I was doing both sales prediction, churn prediction sort of algorithms,
Nice.
and also, chatbots, NLP work, question answering stuff. And then I have like I worked over there, and then I have become a Google developer expert in machine learning, because I was doing community work at the same time, giving workshops and such. And I did I did I started my master's in data science.
Mhm.
I'm doing like I'm also researching on NLP at the moment, like morphologically rich and low resource languages like
Amazing.
Turkish. And I was working. I started working in another company again as a like more of an NLP engineer doing
Oh,
information retrieval problems. And over there, I was using Hugging Face as well. And
nice.
I was doing chatbots again, so I get to experiment with embeddings and stuff. And
Mm.
then I left there for Hugging Face, and I started in Hugging Face as a developer product. So basically, what I'm doing here is that
Mhm.
I am trying to see, like, currently I'm doing integrations, and I am trying to develop the like Keras and non-transformers Keras, and also like transformers Keras stuff. Like I'm trying to help people out as well, and I am trying to like get to communicate the work over there to the users, so that
Nice.
like teach people how to use it and stuff. Yeah,
That's amazing.
that's
That's
currently what
amazing.
I'm doing. Thank you so much.
That's amazing. So I have one last
Yeah,
question for
sure.
you, and that is, like you have gone through a long road. I mean, all of us practically that, like when we start, we all go kind of a long road to learn about machine learning and all. Like for starters, like for people that are at the beginning, what are your advices for them? Like to
It's so
make
I
it
don't
short.
really like I wouldn't like I don't really like giving advices because everyone is built different at the end of the day, and my advice
I mean,
wouldn't
if it
work
was
on
you,
like
like
everyone.
to
Like
your younger self.
if I were to give an advice to myself, I would probably say I don't know. Like I would I would tell myself to experiment even more with things, instead of like um
Theory.
yeah, like instead of theory, I guess, because I know theory, and like everyone is like either more practice kind of person or theory kind of person, and I would probably tell myself to practice even more than theory instead.
Nice advice. I think I would have done the same as well. Thank
Yeah,
you.
happens to the best of us, I guess.
Thank you so
Thank
much,
you so
Merve.
much.
It was an amazing talk, and like I'm glad to host you today. And of course, let us see you tomorrow.
See you tomorrow.
Yeah, see you,
Bye
everyone.
bye.
Thank you.